Hello students, welcome all of you of B.Sc.TY student. Semester is 5th semester and paper is linear algebra. Our lecture is 12th lecture. This is the 12th lecture. In previous lecture, we defined what is meant by quotient space. What is meant by quotient space. Now, we are going to discuss one lemma. We are going to discuss one lemma. I write here statement. If V is a vector space over field of and if W is a subspace of V, then this V by W. So what is this V by W? V by W is set of all possible cosets of W in V over the same field of. And this V by W is called quotient space. So we have to show that this V by W is a vector space. This V by W is a vector space over the same field of where for this is element nu1 W, this nu2 W, these are element of V by W, and alpha is the element belonging to field of satisfy certain condition or take the binary operation as indicated by following things. So this is nu1 plus W plus nu2 plus W is equal to nu1 plus nu2 plus W. And second point, scalar multiplication, nu1 plus W is equal to alpha nu1 plus W. And V by W is called the quotient space. Is called quotient space. So you recall what is the definition of vector space? So we know that if V is a vector space, then which things must be satisfied which property? So V plus is an abelian group. And one condition is that scalar multiplication. That means for the any alpha belong to field, and any new belong to V, their product must belong to V. So here set is given that V by W. V by W is the set. We know that. Proof. We know that in V by W, which element are there? In V by W, so new plus W such that this new belongs to V. This is a set. Okay. So in a V by W, there are which types of element? New plus W. Now we have to show that this V by W is a vector space with binary operation addition plus V plus. But it is given that how we can do the addition of two elements of V by W. So how can we do this? So new 1 plus W and new 2 plus W, addition of this is in this way. Okay, because V is vector space. So if V is a vector space, then for any new 1 and new 2 belonging to V, new 1 plus new 2 belonging to V. Obviously, because V plus is an abelian. So this element must belong to capital V. So again this element must belong to V by W. So new 1 plus W and new 2 plus W, we can take addition of them is new 1 plus new 2 plus W, and this element must belong to W because this element belong to V. Correct. Next is alpha into new 1 plus W. So here alpha new 1 plus W, because this new 1 belong to V, this alpha belong to F. So alpha belong to new V and new belong to V, and alpha with the element belong to field, but their product is in V. So here this new 1 element of V and this alpha element of field, so multiplication is in V. So this is element of V plus W. So again this element is in V by W. See here. Now we have to show that V plus is an it is abelian. Now here V by W is closed with respect to addition. No problem. According to this way and this way, V by W is closed with respect to addition. This condition shows the closed with respect to addition. And scalar multiplication as the defined above things. Now first we have to show that two compositions are well defined. That means they are the independent of particular representative chosen to denote the coset. So this both operations are well defined, no problem. Both operations are well defined, because if we choose new 1 plus W and new 1 dash plus W for new 1 and new 1 dash belongs to V, so here in previous lecture, that means third lecture, we have discussed this. So meaning is that new minus new dash must belongs to W. Next condition I choose nu2 plus w and nu2 dash plus w. Here this nu2 and nu2 dash belongs to V. This gives nu2 dash minus nu2 dash. This element belongs to W. Now W is a subspace. What is given that? W is a subspace. So W is a subspace. So this belongs to W, this belongs to W, implies that some of them also belong to W. So this nu minus nu dash plus here we choose nu1 and here nu2. Okay, no problem. Nu1, nu2 dash and nu2 minus nu2 dash. So this element must be belong to W because this belongs to W, this belongs to W, so there some must belongs to W. So if any element, that means nu1 minus nu2 belongs to W, I write here this nu1 plus nu2 minus nu1 dash plus nu2 dash belongs to W, no problem. Just we associate this nu1, nu2 taking minus sign common and nu1 dash, nu2 dash. This belongs to W. So I write here that this W plus nu1 plus, or I write this side, no problem, nu1 plus nu2 plus W is equal to nu1 dash plus nu2 dash plus W. These things we can write from these things. This take as one element, this take as second element. So here nu1 minus nu2 dash W can be written in this way. Statement is this, so we can write this. Vice versa, if nu1 minus nu1 dash belongs to W, then nu1 plus W is equal to nu1 dash plus W. So here nu1 plus nu2 plus W, see here, nu1 plus nu2 plus W is equal to nu1 dash plus nu2 dash plus W. So therefore the addition in the V by W is well defined. No problem. Now we discuss about the multiplication. Scalar multiplication is well defined or not well defined. Again, I choose the any alpha dash belong to field here. Then alpha minus alpha dash belongs to W, implies that alpha, nu minus nu dash belongs to W. Nu minus nu dash belongs to W. And if we multiply like this, belongs to W. So meaning is that we can write alpha nu plus W is equal to alpha nu dash plus W. First class. So scalar multiplication V by W is also well defined. No doubt. So by which way multiplication and sum is given, so both are well defined things. So what's the remaining work? Remaining works that show that commutative addition, existence of additive identity, existence of additive inverse, that is V plus is an abelian, V by W is an abelian, and remaining 4 properties. So in next lecture we study about the remaining remaining properties of the vector space to show that V by W is a vector space. So thank you. Just revise it. We will meet in the next lecture. Thank you. Thank you very much.